Hello, this is Randy Allen from Engraving Concepts out of Arlington, Texas. I'm here hosting a virtual demonstration of the Epilog Legend series with my colleague Jimmy DuBose. Hello, Jimmy.
Hello, and this is Jimmy DuBose from our Houston office, Engraving Concepts. And we're going to go over the Legend series engraving systems with this video and with this presentation. So Randy's going to start it off. Go ahead, Randy.
Just want to let everybody know that we're going to have everybody on mute, but we do have a chat dialogue you can click on to ask any questions while we're providing the presentation. We'll answer questions, try and go as we go along. If not, we'll get them at the end. If not, you can email us. And then I'm going to start off right away our presentation by just putting in a piece of material. If you were at our showroom at either Houston or Arlington, this is one of the first samples we do in a canned demonstration of taking an anodized aluminum plate, peeling off the protective layer of plastic, and sliding that into the upper left corner of our helix. So I have some can jobs we're going to demonstrate today as if you were right in our showroom. And in the job panel, we can scroll through a list of saved jobs on the machine. Yes, we can save jobs to our unit. So when we push the go button, that's going to move out over the material. And one of the more highly praised, the autofocus function anticipates where that material is, pushes a plunger, and drops it down the right distance away from the lens. So here you see a graphic that we're engraving. And I'm going to ask Jimmy to show that on his screen, what that artwork looks like while it's engraving.
Okay, so here we can see the artwork that Randy's engraving of this ship, this clip art that actually shows some different shading. The laser is going to represent this with density of dots. It's called dithering, and you'll see that Epilog does an excellent job of representing this artwork that way. I'm in Corel Draw right now. So you see all the layout here on the actual plate size, which the plate size actually is a business card size, 3.5 by 2. When we have our artwork completed, we're ready to print. Epilog systems are just set up like a print driver. So I'm just going to go over here and click on print. And you can see I've got my Helix 60 watt selected here. I click on my gear, which takes me to the preferences for that driver. You see our interface where you can put in your speed and your power for vector or for raster. I'm going to go to advanced. And I'm going to scroll down. I'm going to select my ship settings that I had already saved and click on load. That's going to populate everything here in the general tab. Resolution, autofocus, that's on raster, and also the dither method. Actually, the dither method we're going to use is standard on this. All right, so once I click on OK, you basically see all your settings and you see your preview here. You click on print. And let's take a look at the finished result over on the laser.
So here we have it wrapping up, etching the anodized aluminum plate, moving at a very high rate of speed, firing that laser as if it were dots. And the grayscale, as Jimmy mentioned, from the artwork is automatically applied to the material. So the Epilog is doing a great job of acting like a high-resolution, high-performance printer. And so as you can see, there's no complicated software you have to drive or use. You just open your design software, print it through the printer driver with a certain speed and power, and push go on the laser. And so when this finishes, we're going to show how long it takes to burn that. We'll pull it out. And immediately after it's done, you can touch it. It's cold to the touch. Pull it out of the machine and see if we can get a good close-up of the detail. So Jimmy was talking about the halftones and grayscales. Folks, this is automatic from even our low-end systems can pull off this kind of quality. It's just beautiful. The laser technology is wonderful, and it is consistent. So what we're going to do now is I'm going to flip that piece of material over. Here's the time it took. Most of these in a business card format size is about 2.5 minutes, 2.5, 3 minutes or so. But I'm going to flip that over, and then we're going to put that in the corner, and now we're going to burn a photograph. And so in this photograph, you're going to find that it's going to burn white. And what's important about this, I'll touch on this before we hand it to Jimmy, is that the image you're going to see in the artwork is a negative. So anytime you're burning material that burns white, and this is relating primarily to photograph engraving, you always want to print from a negative. So, Jimmy?
So here's the image that Randy is running right now. This is a 200 DPI image, and as you can see here, it's actually, you can see it's kind of coarse to look here, but it's also inverted, as Randy mentioned. So when you're engraving on a piece of material that gives you the engraving is white, you must invert that image so that the positive comes out in your finished result. Other materials that are like this would be like acrylic would be the same way. Black granite would, you have to invert it. So anything where your engraving is white. If you're marking on wood, for example, you would not invert the image. We would still print it much the same way. You click on print, set your speed and power settings, and then send it over to the machine. Again, let's take a look at the finished result.
So here we see a really nice resolution image. The background, of course, was knocked out. So maybe in another video from our YouTube channel, we'll cover photograph engraving. But as a demonstration, many folks walk into our showroom and want to see, hey, what does this look like if I put it in the machine and etch a photograph? So this can get very high resolution detail. And folks, this was printed at 200 DPI, 200 DPI. So when you get up this close, you can see every pixel, but at arm's length, it looks just really knocked out. So the time on this, because of the resolution was being so low, doesn't take but right there, a minute, almost a minute and a half for a full-size business card photograph. So the speed at which these machines can move is very quick. All right, so now we're going to set up for the next project. And then this is going to be a piece of 1/8 inch cast acrylic. 1/8 inch cast acrylic. And Jimmy, in just a second, he's going to have this layout up on his screen. But he's also going to talk about the different types of acrylic. In this particular acrylic being cast, it's going to burn white. We'll let this get started, and then we're going to toss it over to Jimmy. I'm going to scroll through our list of jobs on the display. And so these are all saved on the machine, and then push go. So the autofocus feature is kicked in where it'll touch the material and then drop that down 2 inches away. Jimmy?
Okay, so the job that Randy's running right now is this key ring, little keychain that we made. Of course, you can see that everything is reversed. When you engrave on acrylic, you typically want to mark on the back side. Just looks better on clear acrylic. So we have that mirror image. The red line is, of course, the cutout. You'll see here when it goes to cut it out, that's going to cut out the inside of this hole right here first, and then it's going to cut out the outside. That's our inside-out optimization. Okay. Whenever you look at different types of acrylic to engrave, we're using basically cast acrylic. So a cast acrylic is going to give you a really nice white contrast when you go to engrave it. Extruded acrylic is the other type of acrylic that whenever you go to engrave it, it has more of a melted look. So anytime you're going to do any kind of engraving, you want the engraving to look good, you want cast. As far as vector cutting, they're pretty much the same as far as the results on vector cutting. When I go to print here, and I go to my settings for this acrylic job, again, go to advanced, and I've got my setting in here for my Harley acrylic. Load that setting, and you can see here that over on the vector side, we've got speed, power, and frequency, and our frequency is maxed out. All right, so again, the frequency over here is maxed out at 5,000. That gives us a nice glossy edge. You might decrease this number if you were cutting into wood or paper, which prevents basically a scorched edge. So wood or paper might be at 500 and acrylics at 5,000. All right, so I'm going to click on OK. There's our preview of our job, and we hit print, of course. I'm going to cancel out, and let's go back and look at the finished result on the acrylic.
So as it's finished, it's going to cut that out. As Jimmy indicated, the hairline is set to be our cut line, and that is moving at a slower speed and higher power to slice through this piece of acrylic all the way. Many folks that walk into our showroom and get demonstrations like this, they're just amazed that they can do all of this with just one machine. And you can find many businesses and industries that could certainly benefit from this type of acrylic, this type of material, signage, badge material, or keychains, promotional products. So that was cut all the way through And then the laser engraving is reversed so that when we flip it around, we typically engrave on the back and then flip that around so we see through the front in a clear surface. So when we pull off the protective paper, we see a really nice, gorgeous engraving. So, and you could put anything in here. You could put almost any material with almost anything digital. So it doesn't have to be out of CorelDRAW. It doesn't have to be this logo. It could be just about any logo. So whatever you can get digitally into a graphic software and print to a printer, you can get some gorgeous renditions on many different materials, including cast or extruded acrylic. All right, so this took about, yeah, almost 2 minutes, not long to etch the business card, and that almost took up the full size. And then we cut that out. So we're gonna set up for our next job. And then in this job, we're going to take a piece of wood, and this piece of wood is going to be a fixture. Now this fixture that we're gonna put in the machine is a pin jig, or I'm sorry, wrong job. So we've got the piece of plastic that already, I forgot I already peeled the paper off of that. So we're gonna slide this in. And the reason I wanna do this on this piece of plastic is that we're gonna burn the clip art, the same thing that we did on that metal there, we're gonna burn on this piece of plastic. Now in this piece of plastic, it's got a thin cap layer on top and a bottom layer is substrate. So as we choose through and cycle the jobs and run that same boat with the halftones, the example of running this job is to show you can do that clip art on many different materials, including plastic. So it's actually going to burn through this cap layer that's very thin. And then you're going to see all the halftones and some really nice detail. Jimmy, while this is engraving, talk about the difference in some type of plastics you can't put in a laser, can you?
You should never try to put any kind of PVC material inside your laser, anything that emits chlorine. So the problem is that produces a corrosive gas and it can damage the inside of your laser. This two-ply plastic we have here, of course, is made for laser engraving. It comes in multiple colors. This is a front engravable plastic that you laser through the cap, exposing the core color. They also make reverse engravable that has different colors. You engrave from the backside, mirrored, and then fill in whatever color you need for like a control panel. To basically here, I'm going to go ahead and show CorelDRAW, and you can see the layout that we have here that shows the settings and everything. A lot of questions we get about engraving plastic is what happens if I want to do a whole sheet of these? I'm going to show you real quick in Corel how to do that. So if we do a print preview, and I come over here and I change my table size or my size of my material. Let's say I change that to a 24 by 12. And we'll come back. And then I use this in position layout tool. And here I can just fill up the sheet. So we just come over here and do however many across and several down. And then if I do a preview, you can see all of those plates there on that one screen, on that one sheet of material. And it'll engrave all the way across these. And of course, if I had variable text in these, let's say these were name badges, then at that point, I would do a print merge before I came to this section. And you can print it directly from Corel. Let's take a look at the finished result of the laser.
Okay, so finishing up this job, as Jimmy mentioned, is just going to burn off the surface. Jimmy, have you ever laser engraved a kind of stock that just kind of melts? I think it comes from rotary engravers.
Yeah, so when you go to, the question was, we ever have a problem where it doesn't laser through that cap cleanly? If you ever have a problem where the colors melt together, more than likely you have rotary engraved plastic. The cap on rotary engraved plastic is about 12 thousandths of an inch, and this material that's laserable is about 3 thousandths. The heat it takes to get to the 12 thousandths inch thick cap will actually just cause it to melt into the core. And even with multiple passes, you can't get a clean background. So make sure you purchase laserable material.
How's that coming through on your end? Look okay?
Yeah, it looks great.
Yeah, we're going to zoom up really close in this, and I know many people don't get this close, but I just wanted you to see the halftones and the clip art and really nice engraving of through the cap white plastic into the black. But that is super close and very fine detailed. So the same time in that job, it didn't take as it did the first job. So we just reran that job on a different material. which again is a pretty unique for one machine to be able to throw in one job and run it on several different materials without even making any changes to the machine pretty much. So this next job, now we're back into our pin jig, and so we've got a fixture that's got a V groove cut out of it. Jimmy, a lot of guys will ask, hey, did you cut that fixture out with a laser? You ever get that question?
Oh yeah, I get that question, and of course that was done with the router.
But we've got the pin. I'm going to put that in a very specific location, and we're going to go ahead and run the job, and then we'll look at the artwork afterward. But I'm going to scroll through the pin jig. And one of the questions I get is, can you autofocus on something that's round like that? And the answer is yes. As long as you've got the artwork where it's going to be engraved over the top of a solid surface, that plunger right there is touching the surface of that metal pin, and it's going to burn off that paint. So as it drops it the distance away, it etches very quick in a pin jig like this. So it doesn't take but about a few, I'd say 7 to 8 seconds to actually do the engraving. If we didn't have autofocus on, that would be, minus about 6 seconds. So almost about faster than a bull ride. You can take a name and put it on a pin. And let's take a look at how long. That wasn't very long at all. So 16 seconds. Jimmy, why don't you show them the artwork and what that looks like?
So if you take a look at the artwork here, you'll see that the red lines, we actually engraved those on the fixture itself. And so with that X marks the spot, if you will, going across the Epilog laser, you put your pen, align it with that X where you want the actual text to engrave. And we're not even using our center option with this. We're just using the fixture to align our artwork. So you come over, and then of course you set the red not to engrave. You can do that a couple of different ways. You certainly can use Object Manager to do that within CorelDRAW and just set that layer not to engrave, or you can output by selection only. So let's see what the next thing is that Randy's going to engrave. I'm going to go ahead and hand it back to him.
All right, so 16 seconds, not very long. So a very versatile, high performance piece of machinery that can engrave many different materials very quickly. And you don't have to use fancy software. You can use just about anything that's Windows based. You can print straight to the machine. So in this example, we have a piece of clip art that we're going to engrave on a piece of wood. This is a wood called alder wood. And alder is kind of a medium density wood. It's not hard like oak, but not soft like pine. A little kind of a in between. And so I'm going to scroll through a job called Cowboy. And on our Cowboy job, we're going to have it engrave and cut. So this is going to be a combination job type. It's always going to engrave the images first and then do any cutting last. We'll let this get started. And then Jimmy can talk about wood engraving and then point out some features of the art that we have and show you the dashboard as that job was sent over to the machine. So that auto-focused on that wood. This is about 1/8 inch, not too thick, but all right, Jimmy, show us what you got.
Okay, so we have our layout here of our Cowboy. Just showing you that basically the red is the cutout, the black is the actual engrave. And if I zoom in on that spur, you can see those lines go right up against the engraving. And Randy's going to show you the quality of that when we're finished engraving the piece. Another thing I want to point out on this is just the optimization. We're going to set it to inside out as far as our vector sorting. And it's going to cut these inside circles and also the inside part of this, the Cowboy right here, before it cuts the outside line. And that's very important so that those inside parts are going to drop free. If you cut the outside first, the whole piece could move. Therefore, these holes wouldn't be in the right location. Let's go ahead and go to print. And again, going over to our settings for the driver. And then I'm going to load my settings for the Cowboy. And if you look over here, this is that vector sorting I was telling you about. Again, you want to have that turned on. And I'm using inside out versus optimize. Optimize will just run through your entire image and find the fastest way to engrave all those vectors. Inside out always engraves all the inside pieces before the outside. The other thing I want to show you is what we have here for our frequency. Remember on the acrylic we did 5,000? We're doing 400 on this wood, so it gives us a nice brown edge as opposed to a scorched black edge. We certainly have autofocus on, and we've got our resolution and everything set. So I'm going to click on OK. Of course, we click on print here. And let's go ahead and take a look at the finished Cowboy.
So as that's finishing it up, it's about to start cutting, which really interests a lot of folks for demonstration purposes. When you come and see your first laser demo, it's quite fascinating to see how one machine can engrave and cut. And when it starts to cut through that wood, boy, get a lot of oohs and ahs about the potential and the benefit to something like this. A tool in any shop, small, medium, or large, industrial, cutting out something that fast, that accurate, could benefit just about any craft hobby woodworker or industrial shop. So it's going to cut through that all in one pass, and then we'll pull that out. We also had air assist turned on, a little compressor that pushes air through the tube. Jimmy's going to talk about this a little bit later, but the air assist tube pushes air at the point that the laser beam hits the material, so it helps push down any fire and smoke away from the cutting spot. So breaking that free, we can actually pull the figure out of the scrap piece of wood. And I'm going to do my best to poke out these little bullet holes, and then without breaking off that spur, which is really what I want to show is after those are pushed out, the spur, you saw that in Jimmy's artwork, that if we zoom up on that real close, I mean, you can see that the accuracy of these servo motors are extremely effective in producing high detail resolution cutting. Right around, see right there. I mean, it's just gorgeous. Very clean, crisp engraving. All around the side, as he talked about frequency, where the edges aren't too charred or burnt. Nice clean edge. And again, that's zoomed up really, really close. So it doesn't take much time to burn and cut something like that. And if you had a large sheet of wood, as Jimmy saw, you can actually populate all of those. Any one of these, the cowboy, you could take this Harley Davidson, a whole full sheet of acrylic, and lay it out the table. You could take these metal pieces. You can either put those in fixtures and populate those all the way across the table and burn many with different variable data from an Excel spreadsheet you can populate. And then promotional products like ink pens and dog tags and even plastic signage. So if you're in our showroom, we'd have a lot of these samples. You need to be taking some of these samples home with you. So feel free to certainly look us up. But now we move into the next project of doing a glass. So yes, you can laser on very inexpensive glass. This is just a dollar glass, 99 cents. So we're going to step through, if you're in our showroom, do a full demo on how we would lower the table to accommodate our rotary fixture, what we call our rotary glass attachment. So when we lower the table, we're making enough space, and when we put the fixture in, that we'll have plenty of clearance, so it's not going to move out and collide with our fixture. But first, we're going to flip our rulers back, and that's what allows us to open the honeycomb or grid table. And then once we pull out our honeycomb, and Jimmy will talk about this a little bit, about the different grids we have. Then there's also what we call a crumb tray. And so this crumb tray, when we open that up around the front, we can pull that out. So all those little pieces from the cowboy or acrylic keychain fall through, we're able to dump those out quite easily without much effort, keep the machine clean. And you don't want a lot of debris going down in there and catching a fire. So we want to always keep that clean. So now what we're going to do is we're going to move in position so that you can see the connector that the rotary fixture is going to plug into. And it's got some pins that are strategically located in the table. These match up with the rotary fixture itself that are going to hold those pins. So I take my rotary attachment here, and this is the little connector that we use. Let's turn that over and look at the pins. So these pins are what's going to sink into each hole in the fixture or in the table. So when we're going to flip this back over, we're going to make sure that we're going to read a certain label. You saw the tag there. So this tag that's connected, that blue anodized aluminum, is very important to read. Every new owner, operator needs to be sure that you always power the unit off before you plug or unplug this connector. So always make sure you power that off. So this is actually going to plug right into the back, and I'll reposition the camera here so we can get a better look and all in one shot. But I'm going to show how you want to make sure that you always power off the unit. So if that's not getting no power, then of course it is safe to plug in the attachment. So we'll close the door and then plug in this attachment in the back. And then what I like to do is use the right side pin to kind of pivot off of. So I'll take that pin and push that back right in there, move the cable out of the way, and that other side of the other two pins will just drop right into place. So now we always want to be sure, good practice to keep our rulers flipped down for no collision. And then we're going to slide the back stop away so we can adjust for the glass we're going to put in. There's also a clamp on that left side that we use to kind of clamp materials down to those drive wheels. Jimmy, you want to talk about that clamp on the wheels for a moment?
Sure. So the clamp basically keeps pressure on the drive wheels so that when you're engraving something, it prevents it from slipping. If the object's heavy enough, like if I was marking on a wine bottle, there'd be enough weight in it that I wouldn't have to use the clip, and you probably have the base of the wine bottle there anyway. But if I'm engraving on tumblers, I'm engraving on glasses, then of course I want to use that clip to push the pressure down on the wheels. Um, this unit is very, very versatile. Actually, Randy is going to show about, he's going to level the piece now using the level on top of the engraving area and the scissor jack on the right-hand side. It's really important that you get your engraving area level, or if you will, perpendicular to the beam. If it's not perpendicular to the beam, what can happen is that you can lose power across the surface. Now, this glass is slightly curved, but it's well within the depth of field of our 2-inch lens, so it'll still be able to mark over that curvature.
All right, so once you have that level, and now what normally we do on most bottles or glasses, or let's say odd shaped pieces that aren't in the corner in the upper left area, I like to use a feature built into our Legend series and most all of our epilogues called the center engraving. So when we power this up, it's going to automatically initialize. The engineers did a beautiful job of making sure that this is very easy to use. So when we power this unit up, it's actually going to initialize out over the center of the attachment. And so that's going to be even right along the x-axis from the rail down to the attachment. And so in this left and right motion, the lens assembly moves back and forth, and it doesn't have to really travel front to back anymore because it's locked into position. And so for most objects that do not go in the upper left, I like to turn on a red dot pointer there that you see. And it's just a little diode. And that little pointer lets us maneuver to a new home position. Actually, by pushing the XY off key on the display here, you see XY off, and then go, lets us kind of do a point and shoot. So I kind of mimic it doing like a drill press. You kind of point the red dot where you want the center of that logo to be engraved. So you don't have to mess with cones. You don't have to figure out circumference or diameter. That's something that many other lasers have to use, but in this easy to use system, it's all pretty much set up and ready to go and act like it's printing a flat piece of paper. So we've set the home position, the red dot pointer. We select our job called glass. We're going to close our door because the laser won't fire. They're very safe. They won't fire with the doors open. And so once we push go, it'll automatically focus right to the surface of that glass at the center point where it's going to begin that artwork. So it's going to rotate back half the distance of the glass, or half the distance of the logo, I should say. And then there we see a bright image engraving. I'm going to have the artwork shown of what this looks like. We're going to toss that over to Jimmy and see what this looks like on CorelDRAW. So here Jimmy's got open the badge, and the badge is, notice the badge is grayscale. So the grayscale is 77 gray. So this badge is not black, and many times as glass, which is not a liquid, it's a solid that expands to keep the chipping down, then we use a level of gray so that it doesn't burn too many dots. And we have found that this level of about 70% of most glass does a wonderful job of etching the glass but not chipping. And so you could use this same method on inexpensive glass or crystal, even granite, tile, and so forth. And so, Jimmy, you want to show them the printer driver?
Sure. So let's go over here to our settings for the glass. I'm going to go and I'm going to load my setting I have for glass here. And taking a look at it, you'll notice a couple things. First of all, that our speed's a little bit faster. Uh, we really just have to mark the surface of the glass. You're not going to get depth into the glass with a laser. If you need depth into glass, you're going to use a sandblaster to do that, which you can use the Epilog laser to do the sandblast artwork by putting film on the glass. We're using a standard dither. I'm using 600 DPI to get a little bit of a finer dither. And of course, center engraving, which Randy already set at the machine, right? You not only have to set it at the machine, you have to set it here in the driver as well, so that the laser knows I'm sending over a center job. Okay, and then we'll go ahead and take a look at the finished glass.
So this image or this glass that you see here is etching white, which is pretty common. That frosted area on the glass is, as he said, not depth. I suppose if you really take some time and technique, you might be able to get it a little, but for most laser applications on a CO2 laser, you're just looking to achieve a nice frosted surface etch, and this is doing a beautiful job. And by the way, this is etched like 300 DPI, and you could do this at 300 DPI, you could do it at 600 DPI, but the dots are really close together. That halftone shows a nice smooth surface etch. And you could actually, Jimmy, you could set that up to go all the way around and do both sides. Jimmy's got a CorelDRAW file we don't have up here, but he's got a CorelDRAW file where you can have it start on one side, it'll continue to rotate and do both logos at the same time. So one logo in a 99-cent tea glass taking 2.5 minutes. Jimmy, what would you charge on something like that?
So let's say we take a look at the glass itself. Costs us $1. A lot of people will do a 3-time markup on that, so that means the glass itself is worth $3. Many people will charge around $2 a minute at, say, 3 minutes. So that means at $9, we're making a good profit on this glass. But of course, you should also take a look at what people charge for engraving short-run glasses. Many people charge a minimum of $15. So, you know, you want to be price competitive, but you also don't want to leave money on the table. So those are some what a lot of people would charge for that glass, somewhere between $10 and $15.
So here what we're going to do is I'm going to spray on some ceramic material onto stainless steel. This is from a company called Enduramark. There's a couple of different brands in the marketplace, but this is required on any bare alloy substrate. So it's got to be a bare metal. Works really well on titanium, stainless steel. It will work on chrome and aluminum. But once the spray or ceramic substance is dried to the mug, then we can put that in the laser and etch it. Let's see. So this is going to also autofocus. And then what I'm doing now, just like I did on the glass, I'm using the red dot pointer. If you can see that there, that red dot, I'm using that to find my mathematical center between the top and that middle section where it starts to taper off. And so not seeing it here on the display, sorry, but we can cover that on motors later. And I actually have a video on how to do this in our YouTube channel in our gallery. But you can actually look at the display and it'll show you the distance, and then you divide that by 2 and you can point and shoot where that is right there from the display. So with the red dot on, I'm going to choose the job to be engraved, and it's going to auto focus on that, drop it down to 2 inches away. But this is a very popular product, the steel tumblers, of course. But Jimmy, you don't have to use this ceramic spray on the powder coateds, do you?
No, if you're lasering a powder coated tumbler, there's no prep work that needs to be done. You basically put the tumbler in and you laser engrave it. The laser will remove the paint showing the stainless steel underneath. There might be some residue inside those characters after you engrave. Many of our customers use degreasers to clean that out. Zep is a real popular brand you can get at home improvement stores in your area. It seems to work pretty well. We also have some customers that use Awesome Spray, which you can get at dollar stores.
So this is a pretty much just a solid black logo. But you could still use the halftones that we did on, say, the photograph or the boat, the piece of clip art, can all be put in to Illustrator or CorelDRAW and basically printed to any substrate. So as long as your alloy is a clean substance, there's no clear coat, there's not a polish on top, then you can apply the ceramic spray. It also comes in a paste, but I think most of us like the spray for convenience. Cans are a little bit more money. The paste you can get a little more life out of by diluting it with denatured alcohol. But I think for the high volume production shop, it's pretty convenient to have these spray cans handy. So once you spray these ceramics paste to the metal, you have to let it dry. It doesn't take long, but once that's dried, as we laser this, this is turning black. Now, there's been times where I lasered material that had a clear coat, but you can't really tell that until you go to wash this off that it might really not stick. So it will be black here, but that doesn't really mean it's gonna work. So be sure to, any material that you want to apply this to, whether it be silverware, kitchenware, knives. Knives are a big product line using a CO2 or even a fiber laser. Now, fiber lasers can burn steel like this without this ceramic spray. But the problem with fiber lasers is, generally speaking, as a general rule, most fiber lasers are super sensitive to any change in focus. And if you have any kind of major curvature, or the slightest curvature, I should say, to a mug, then you may get hot spots where one part of the engraving looks better than another, or one part is darker or rougher than another. So we have found that these, for the stainless steel mugs, to get a good black, it's really hard to beat the ceramic spray paint, because we're applying a spray paint to the surface of the metal and not doing much to the alloy itself. And so once you spray it on, you let it dry, you burn your image, then what we're going to do is we're going to walk this over to the sink and we're going to wash it off. Doesn't take any crazy kind of cleaner. Doesn't even take a degreaser to clean this ceramic spray from the mug. But there is a material. So the folks, the supplier Enduramark, they also sell, what was the name of that stuff that you can use to clean stainless steel?
Duramark sells a product called Blue that actually will go through and it'll clean it. It does the same thing that that basically the degreaser does. It's just some people feel that it does a little bit better job.
And so not only cleaning mugs like this with water, but if you have a powder coated mug, then the Blue from Enduramark or ZEP 505, or there's some stuff called Awesome on the market that cleans the residue from the powder coat off really, really nice. So you don't have to run mugs more than once. If you're running your mugs more than once to try and clean off the residue, it's much easier, more effective just to run it once. You'll see a little residue there, and then just clean that off with a detergent. You shouldn't really have to run your mugs more than once. So you see, there wasn't much effort to this. We just put it right under the water, and the ceramic spray just falls right off. It's permanent. This is acid bath tested, salt water tested, heat tested, UV light tested, so it's extremely durable. So any kind of stainless steel mug, any knife, kitchenware, hunting gear, if it's a bare metal, then you're good to go. So
Randy, let me show a layout real quick while
sure.
you're showing the quality of those images.
All right.
So this is the layout that Randy ran, and just showing you, this is just basically the size of the marking area. You don't have to put in the circumference unless you want to mark all the way around the piece. As you can see in this layout, and of course this is a CorelDRAW job I can offer for you, but in this case the Epilog laser is on one side and the name is on the other side, and this is if a label we had wrapped all the way around. We center this text basically 3/4 of the circumference, and this is 1/4 of the circumference, so that when we engrave, you're going to set a home position in the middle of those two, and just you run it and it's going to engrave on both sides at one time. Obviously the embossed part, the Yeti, Arctic, or whatever manufacturer that's embossed, is going to be centered at the front. But it's pretty easy to run both sides if you have the right job and layout. Let's take a look at those finished samples.
That's a fantastic layout that you showed there, Jimmy. I really like showing that, going 2 logos all the way around. And, you know, we can help supply that. We provide a lot of training for these machines, but the versatility on these units is fantastic. I mean, acrylic and metal and plastic and wood, all done with one machine. Flatware, roundware, promotional products, keychains, dog tags, pins. I mean, it's pretty fascinating to do all of this work with just one machine. So this is just a sampling of the things. If you came up to our showroom, either in Houston or Dallas, Fort Worth, and Arlington, a lot of these products we have samples for. We can test your own products. So if you wanted to bring some materials or ship it to us, we could have it tested, and we can provide either live or video or in-person demonstrations. So we wanted to take a minute to kind of do maybe one last project. We don't want to forget leather, a very popular product in our industry. Jimmy, you want to talk about leather a minute?
Sure. So Randy's going to mark here on leatherette, which synthetic leather. It's real popular for laser owners because it marks so nice. It's very consistent, available in multiple colors. But you can also mark and you can cut natural leather as well. Natural vegetable tan leather marks with great contrast. You can even do photographs on it. I have some of our customers that even cut their own lacing out of different kinds of leather or suede. The laser is very versatile when it comes to marking on leather.
Yeah, you can also cut through leather. You could etch it and cut it out. We have some saddle makers, and what they do is they have the tools that they kind of stamp, hand stamp letters or decorative images in the Western wear and the Western gear of saddles, and they will use those hand tools. But what's really nice about the laser is you could use the laser to draw with. So they'll scan artwork or download artwork from the internet, and those Western patterns they would basically send to the laser and have the laser kind of just draw a rough marked area on where they need to put that knife and then go by hand. Because in the old days, without lasers, they'd have to trace those with a pencil and paper and trying to put down where they want that design to go. But now with laser, it's really been a game changer for many different industries. So promotional products, as he mentioned, leatherette. We've got a lot of boot makers that use our laser for prototypes. So like I say, it's going to complement the business aspect, because if you're doing hundreds of thousands of boots, well, you're going to have probably a steel rule die to punch those out, but you're going to want to not have to make a die every time you test one. So laser is very effective in prototyping. It can cut tool foam for shaping of tools. Don't have a sample of that here, but you're going to find that this leather just burns really nice, crisp and clean, really dark. So you're kind of always looking for images and materials that will show good contrast. And so not much work to get that done. High speed, low power. All right, Jimmy, you want to start on features of the Legend series?
Absolutely. So the Legend series comes with a 2-year warranty. Epilog's warranty covers all the components on the machine. We don't have any exclusions. That means that your belt, your optics, which some other manufacturers feel are, you know, consumables, Epilog doesn't look at it that way. They basically cover everything on the machine for 2 years. You can also, one thing that's unique about Epilog is that we can connect not just USB, but we can connect via Ethernet. Basically, networking your laser is a great advantage because multiple computers can now connect and send jobs to that laser if it's on the local network. If you're connected to the local network, any computer that's wirelessly connected to that same network can send jobs, or you can use a range extender or a network switch that's wireless to connect to your laser and make it wireless on its own. And Randy, as he just did there, put lasers. So we do have the other situation where you have, let's say you have 4 or 5 lasers and you have one computer. It works the other way too, not just multiple computers to one laser, but you can have one computer that can run multiple lasers across the network. And that's a great advantage when it comes to production. Anything to add, Randy?
No, I think that covered it really well. I mean, running it to a wireless switch or router, we have many customers that are running multiple lasers, and it's extremely effective because when you run a system where it's just USB only, if your computer dies in the middle or you get that blue screen of death on a Windows computer who hadn't had that at one point, then some of the lasers are just relying on that USB connection, and it'll die and kill the job and that $60 piece of acrylic or crystal. So the nice thing about our systems on the Epilog is that when you send that job through that network connection and it lands on the machine, that job is on the motherboard, in the memory, on the unit. If the USB or the Ethernet was unplugged, that job would still be on the machine, ready to go. Go ahead, Jimmy.
So Epilog makes their own tubes. They're waveguide laser tubes. They're manufactured in Golden, Colorado. They do all the quality control there. It's an all metal design. These are not glass tubes, and it's air cooled. So a lot of times when you hear water cooled on lower wattage CO2s, they're glass tubes like bulbs. Don't have great longevity. They don't have great power control, but Epilogs are air cooled, and they're basically RF controlled. So the radio frequency control gives us great control over the power of the tube. We can even kiss cut materials where you have two materials that are on top of one another, like a tactile twill, and you cut through one surface, the top surface, but not the bottom, and then you cut through both. The design that we have has higher beam quality and longer life with a lower recharge cost. So inside the tube, we have components that are coated with ceramic, and that ceramic actually prevents the degradation of the gas inside the tube. It prevents impurities basically being introduced inside the tube. So, but our design actually allows for those to be adjusted, to the internal components to be easily rebuilt. Whenever you do have a tube that, say, your past 2 years, maybe somewhere between 3 and 8 years, and you need to have it recharged, well, Epilog has those tubes on the shelf. They send you a recharge tube. You send back your old tube as a core, and then you pay basically the recharge amount, and that tube you get has a 2-year warranty. All of the Legend series use servo motors and also linear encoders. The servo motors, the difference between that and, say, for example, a stepper motor is that a servo motor gives continual position feedback to the controller. That means if anything happens at the motion system, it has the ability to adjust. Let's say that something happens where the belt sticks or the bearing stick. It's possible for that motor to make an adjustment and your engraving will still be good. It's a much more sophisticated method of operation compared with a stepper motor. We also have linear encoder that we use. Basically, the motor has an encoder, but we also have a linear encoder that's used simply for the firing of the laser beam. This is located on your bridge, and as the carriage goes back and forth, it gives an accurate position of where the lens is located back to the tube, so that whenever it goes and fires for those individual pixels inside your photograph, those are all placed accurately. If you're lasering for a line of text, the edge of that text is nice and straight, because when it fires right to left and left to right, everything lines up. So again, part of the reason why Epilog systems produce such great quality is the quality of the components we use.
Yeah, I want to touch on that too, Jimmy. Back up one slide if you could. Me and you can talk about this a second. You hear a lot of stuff on the internet. What's the right way to have a motion control system? And I mean, these engineers have gone to great lengths over 30 years to develop these systems for high performance speeds, but also very accurate and high quality images. You would never say that this is an inferior type linear encoder to anything else. I mean, it's a very high performance, right?
Right. It's the linear encoders that we use here. Again, it's just for accuracy and firing, and that allows us to get that image quality that you see in all the samples on the Epilog site that you'll see in our showroom.
Yeah, and there may be cleaning involved, but it's really not a there's not a downside to using something very robust like this, and so it's able to be cleaned and it's able to be maintained. He's going to talk about belts. Go ahead, Jimmy.
So before we get to the belts, we're going to talk about the radiance optics. Again, things that Epilog does in order to get the finest quality possible. So the beam, as it comes out of the laser tube, is expanded and then collimated. And what that does is it gives us a larger beam going into the lens. With a larger beam coming into the lens, It means that we get a finer point on the material. Also, the beam itself is, the shape is rounder. That also means that when I burn a pixel, when I burn an image, that those individual pixels are as small as they can be, they're as round as they can be, so that the finished image looks so good. Now, this Radiance Optics package is available. It comes with, included with, the Mini 24 and the Helix, but not on the Mini 18 because the Mini 18 is a little bit too small. The table size is so small that we can't really take advantage of this optics package. Epilog also uses B-style Kevlar belts. These belts are reinforced, of course, with thread, and so you don't have the stretching at high speeds. It also gives a nice accurate position. When you look at a motion system, you have to come down and find, okay, where's your weakest link? So even if you have a great encoder, if you've got a belt that stretches, well, that's gonna affect your image quality. If you have bearings that are not good, that's gonna affect your image quality. So all the way through the system, Epilog uses the highest quality components. Our lenses that we use on the Legend series, they're all rated to 500 watts. And if you know our systems, you realize, well, wait a minute, the Helix has the highest wattage, it's only 80 watts. Yeah, that's right. So Epilog systems are overbuilt in this case. So that 500 watt lens is going to give you superior quality to, say, a lower rated lens. We have 3 different lens options available on the Legend line. We have our standard lens, which comes with the system. That's a 2-inch lens. It's the most versatile. Think of it as like the Swiss Army knife of lenses. It does a great job of engraving quality and also on cutting. If you need a little bit finer quality, you can get an optional 1.5-inch focal length lens, which gives you finer detail. But the trade-off is that your material needs to be very flat because what we call the depth of field is much less on a 1.5 versus a 2. Then you could go to a 4-inch lens. It has a bigger spot size, but the depth of field is greater. Let's say you were going to mark on a basketball and you wanted to laser basketball for a tournament. You want to put the MVP's name on there. Well, if you're using a 2-inch lens, you can only mark on a very narrow part of that basketball. There's no easy way to turn that, so you can't put it in a rotary attachment. But if you go with the 4-inch lens, you now can mark over a greater area of that basketball. Also, curved glass awards are very useful with the 4-inch lens. So you wouldn't use it all the time because it doesn't have the finest spot size, but when you have an application where you need to mark over a curved surface, they're great. Looking here at our lens assembly, Randy was talking about using air assist before. You can see that we have that curved air assist line. That's directed right at the point of cut so that it blows down there and tries to prevent any kind of flame up on the material that you're marking, which can scorch the material. You can see also in this design that you've got the focus plunger. The focus plunger is what touches off on the material. If you can't use a focus plunger, let's say you're marking on, oh, I don't know, like a fleece jacket, or you're marking on some sort of soft material that you know the plunger hits it's going to push it down, like a koozie, for example. That's what those 2 posts that stick out there that are sticking up just below the lens assembly. You put a manual focus tool on there, and that manual focus tool gauge, you basically raise the material up, the table up that is, until it engages that manual focus gauge, and then your focus is set. You remove the gauge and run your job. You can see here too that you can see a view of the mirror. The beam comes and hits the mirror and directs it 45 degrees, or I'm sorry, 90 degrees straight down into the lens. Right, Randy just drew a line showing that, okay? All right. We use long life steel bearings on our motion system for the Legend line. What this means is that this gives us great rigidity and also gives us great accuracy, and it can handle the speeds that we travel. So you can see the cutaway design here. It shows that you've got ball bearings that are running in an elliptical race, and they basically run through like follow the leader, if you will, and they ride along that steel bearing inside a machined groove that matches the diameter of those bearings. There's also sealed off, so you've got sweeps on this rail to prevent any kind of debris getting inside there. But every 3 months, you're supposed to clean and lubricate these bearings. We usually just take, alcohol or a degreaser and you wipe the rail down. It'll have smoke residue and other things on it. Then you come back with some lithium grease in a syringe that's supplied by Epilog, and you put some lithium grease in the top channel and the bottom channel of the rail. Manually move the lens back and forth, and it pushes the grease inside the bearings. Okay. We have an integrated downdraft table on the Legend line. What that means is that the suction from your exhaust fan is going to pull air through that table. So if you have the steel table, which you can see there in the upper right-hand corner, see if right here, you can see that steel table, if you put, say some paper or some thin fabric on that table, and you cover up all the other holes, when you turn on your fan, it's actually going to pull that down. And that's very useful for thin material. That same table, this same table right here, also, you can use magnets to hold material down. Okay, so it's a stainless steel alloy that has enough iron in it that you can use magnets on it. If you take that table out, you can also come and use your honeycomb table. Your honeycomb table here in the bottom right-hand corner. The use of this table, it allows you to cut out through material like wood and acrylic and plastic, and the fumes will escape underneath. By letting those fumes escape underneath, you prevent damage to the bottom side of the material, and also you don't get the reflection off the stainless steel table when you're cutting through, when you're using that vector grid. All right, so I want to finish with just reminding Epilog is made in Golden, Colorado. They make all their tubes, they make all their systems. Engineering and customer service is out of the factory at Golden. Phone service is always free also from your distributor, Engraving Concepts. Randy, do you have anything to add?
No, I just want to let everybody know my email address is randy@engravingconcepts.com out of the Dallas-Fort Worth office. And Jimmy's email address is jimmy@engravingconcepts.com. We certainly plan to see you at a live demonstration at our facility in our showroom. We can provide virtual demonstrations online, one-on-one. You can ship us material that we can test. So yeah, this particular video, and we'll do other demonstrations, but this one is for the Mini Helix 18 and 24 Legend series. So Jimmy, thanks for working with me today. We appreciate it.
Thanks everybody for attending, and we look forward to seeing you soon.